All right, guys, in this video, I'm going to try both of these trigonometric problems right here. So in both questions, I'm asked to prove that the given statement is true. So first problem, I'm asked to show that 2 tan of A all over 1 plus tan squared of A is equal to 2 sine A cosine A. All right, so let me take this one down here. Let me just line here. So this is where I'm going to try the problem. All right, this is question number 16. 2 tan of A over 1 plus tan squared. We want to show that that's 2 sine A cosine A. All right, well, first thing I realize is that 1 plus tan squared of A, as we know, is just secant squared of A. So my denominator is secant squared of A. It's 1 plus tan squared. And in my numerator, I have 2 tan A. Well, tan is sine over cosine. And so 2 tan of A is really just 2 sine A over cosine A. So this is 2 sine A all over cosine A. Secant squared, well, I know that secant is 1 over cosine. And so secant squared is 1 over cosine squared. So I'll write that. Continuing, my numerator is 2 sine A cosine A. 2 sine A over cosine A, I should say. And then my denominator, secant squared, is 1 over cosine squared of A. All right, well, I have a fraction in the numerator, a fraction in the denominator. I'm going to invert the denominator and multiply. So this gives me 2 sine A all over cosine of A times the inverse of the denominator is cosine squared of A all over 1. And what's going to happen? Well, in my numerator, I'm going to end up with 2 sine A cosine squared A. My denominator is cosine A times 1, so I just have cosine of A. And one of my cosines in my numerator is going to cancel with the cosine in the denominator. So one of these I should say, will cancel with the cosine in my denominator, and I will be left with 2 sine of A cosine of A, which is what I set out to prove. So that's that first one. All right, let's try to tackle the second question. Just remind myself what it is. 1 over sine squared theta minus 1 times 1 over cosine squared theta minus 1 is equal to 1. Can we show that? All right, so for some reason they've switched from A to theta for the angle. That's all right. So 1 over sine squared of theta minus 1 times 1 over cosine squared of theta minus 1. We have to show that this is equal to 1. So this is equal to 1. All right, so what I'm going to do is in each of these parentheses, I'm going to express it as a single fraction. So that is, I'm going to find a common denominator in both of these cases. So on the left-hand side, I have 1 over sine squared theta minus 1. So a common denominator of 1 over sine squared theta and 1 will be sine squared theta. Then sine squared theta goes into itself once. 1 times 1 is 1. I have a minus. And if I like, I can think of this as 1 over 1. 1 into sine squared theta goes sine squared theta times. Sine squared theta times 1 is sine squared of theta. And I can do the same on the left-hand side. I want a common denominator. That, in this case, is going to be cosine squared of theta. Cosine squared theta goes into itself once. 1 times 1 is 1. Minus, again, 1 into cosine squared theta goes cosine squared theta times. And so I have 1 times cosine squared theta is cosine squared theta. And that's that. All right, so I've expressed what's inside the parentheses as a single fraction. And what I recognize now is that 1 minus sine squared, on the left-hand side, if I look at the left-hand side parentheses, 1 minus sine squared is really just cosine squared theta, because we know that sine squared theta plus cosine squared theta is equal to 1. And so 1 minus sine squared is just cosine squared. So I can express this as cosine squared of theta all over sine squared of theta. And this is to be multiplied by, on the right-hand side, I have 1 minus cosine squared theta in the numerator. 1 minus cosine squared theta will be sine squared theta. And so this is sine squared of theta all over cosine squared of theta. And of course, if I multiply these two fractions, top times top, bottom times bottom, I end up with sine squared theta, cosine squared theta in the numerator, and in the denominator, I have the same thing, sine squared theta times cosine squared theta. And of course, my numerator and my denominator are the same, and so this is equal to 1. And so again, we've set out to prove, we've proved what we set out to prove, and so we are done. And that's how we tackle problems like this.